Hello students, and welcome to another video. Today we're going to be talking about mass-to-mass calculations in stoichiometry. This is very similar to mole-to-mole calculations, except for it's really just an extra step or two. Okay, so if you're feeling stuck on this, go back and watch the mole-to-mole calculations, and then you're going to start to recognize the pattern of what mass-to-mass calculations are like. Okay, now here's our kind of methodology of how we go about finding our mass to mass of what we're looking for calculations. Okay, so for example, we have two different compounds that we're looking at. One is G and the other is W. Okay, so it's mass and then mass. Okay, we have a G and a W. So we want to figure out if we have a certain amount of G, how much W can I make? So what we're going to do is we're going to find the mass of G, which will typically be given to us, and we're going to convert it to moles. And then we're going to convert those moles and we're going to compare it to the mole ratio of the two, of the G and the W. And then now we're going to convert the moles of W to the mass. Okay, we're just converting, basically we're extending the problem two ways. Because the mole to mole calculations is simply this. You have a mole, you compare it to the mole ratio, and then you have the moles of the product or the amount that you need or whatever ratio you're looking for, okay? So all we're doing is adding an extra step and putting it out to where we can calculate the masses of it, okay? Right, there'll be a video on this, a how-to video on mass-to-mass calculations that will explain this further, but if you've done those problems and you really want a nice review, take a look at this problem. It will start to make sense to you later after you've learned how to do it, okay? There's an example here. We're gonna do a problem similar to this in the mass-to-mass calculations video. And let's just appreciate this chart here for a minute. Now, if we look here, if we have 100 grams of nitrogen, we can make about 121 grams of ammonia. And now, this chart's going to look a little different than our mole-to-mole because when we're talking about masses, nitrogen is a lot heavier than hydrogen is. So if you look here, the bulk of this ammonia molecule is going to be nitrogen. Okay, so the bulk of it's going to be nitrogen. Hydrogens are light atoms. So if you notice, to make this much ammonia, 121 grams on this graph, you need 100 grams of nitrogen. Okay, so we're just looking at that ratio of if you have this much reactant, how much product are you going to make? Well, if you want this much product, how much reactant do we need? Okay, it's just describing that relationship. Okay, thanks for watching.